Good day, my name is Olatunji Olakunle Olumuyiwa, and this is my capstone project for ECX 4.0 in the data structures and algorithms track. My topic is based on the two-pointer technique. I would like to thank my tutors Lawal Ayobami and Dawood Johnson for their lessons and assignments and all the help in getting through the course. Moving on, um, so the two-pointer technique. The two-pointer technique is an efficient technique used in working with data structures like arrays and linked lists. It helps to optimize operations such as searching for, traversing through, and manipulating elements in the data structure. You know, arrays and linked lists they are, should I say, ordered, but not ordered in the sense that is one thing after the other. You move from left to right. That's so it's same thing with two-pointer technique. It involves using two pointers to move through the data structure. It is common to have one pointer at each end or both pointers side by side moving at similar or different places. So when you're using the two-pointer technique, it's possible you can either have the pointers away from each other or next to each other. The two-pointer technique is a good technique because it helps to eliminate u- brute force techniques such as nested for loops and helps to reduce the time complexity of the solution as well. I remember when I started programming, and most times when I would see problems that where you needed to go through maybe an array or something, first thing that will come to my mind is just nested for loop. And I remember a particular time where I used four nested for loops. Very, very inefficient code. So the two-pointer technique, from what I've seen over time, is that a lot of times it helps to eliminate using nested for loop. So when you use the two-pointer technique, it's usually in cases where you can use a nested for loop, but which will be a brute force technique that is not as efficient. And obviously, the time complexity using the nested for loop will be more than using the um, two-pointer technique. So now let's look at a common example of the two-pointer technique. Is like the go-to example for explaining how this technique works. Yeah. So in this example, we're given an array and we have six numbers in the array. So let's say you want to find which two numbers will sum up to a particular number in the array. Let's say you wanted to find which two numbers will give you a value of 70. So let's say you wanted a value of no, let's do 60. Okay, that was a funny six. So you wanted a value of 60 from the array. The naive approach or the brute force technique using nested for loop will be to iterate through uh, each element and add it to every other element in the array. And that will work, but we're not just looking for code that works, we're looking for code that works and works efficiently. We're trying to get the best possible solution. We want to optimize the solution that we are providing. So here in the two-pointer technique, what we have is that in this case here, you have two pointers. You have pointer one and then you have pointer two. So um, basically, pointer one starts from the left side and pointer two from the right. In this example, and in many other examples where you want to apply the two pointer technique, you want to sort the array because when you sort, it eliminates the need to go through the entire. In some cases, you won't have to go through the entire array to get your answer or to get the solution that you need, because sorting will introduce some um, efficient, how like it will introduce some things that make it more efficient in solving. It will introduce some It helps you eliminate certain things that you otherwise would not have been able to eliminate. So in this case here, we start by adding the extreme ends of the array. On the left, for pointer one, you have pointer one is zero index by the way, so this is zero index. Then you have 1, 2, 8, 0, 1, 2, 3, 4, 5. Then pointer two is at index 5 of the array because arrays are zero index. So you add array 0 plus array 5, which will give you a value of 90 because array 0 plus array 5 will give you a value of 90. But 90 is larger than what you want. What we're looking for is a value of 60. Now, we want a value that will be equal to 60. So what do we do now? If I say let's move the pointer 1 to the right, let's increase the index of pointer 1. Because this array is sorted, we know that if pointer 1 is moving to the right, then instead of the value that we're getting to come down, it will eventually go up. So what you don't want to increase the value, you want to reduce it. So the next thing you do here is to move pointer 2. Let me change the color of the pen. You want to move pointer 2 down by 1, like to the next index. So pointer 2 becomes index 4. Then at this index, what happens? You add up again. You are iterating, so you have to keep on doing other addition. So you add. Why is this not responding? Okay. So you are going to add array 0 plus array 4, which is 10 plus 75, and that will give you a value of what? Okay, that will give you a value of 85. So again, the value we have is larger than the 60, which is our target, and so we don't want to increase the value, we want to bring it down. And the way we bring it down is by um, bringing down the index of array 2. So we move array 2 from index 4 to index 3, which is 50. So array 2 now, sorry, not array 2, pointer 2. Pointer 2 is now at the 3 index of the array. And we add. So we are going to add array 0, then plus array 3, which is what? 10 plus 50, which is going to be 60. So having done this, we now have the two values that add up to give a particular target. In this case, the target here is 60. So our two values in this case are 10 and 50, which occur at index 0 and index 3 of the array. So now we can return our values. This what is the time complexity for this? The time complexity for this obviously is not going to be n O of n square. The time complexity for this, there's no loop here. Okay, there's just you're running only one loop. So the worst case scenario is O of n. Maybe there's no what's it called? There are no elements in the array that will add up to 60. So what in that case, what happens is that you keep on moving until you get to um, every element in the array, and then eventually you don't find what you want. You don't return, you return like an empty. You just don't return any of the elements in the array. So that is the worst case scenario the for this use of two-pointer technique. So this example is very basic, but it shows how the two-pointer technique works, and it shows how it is used in optimizing and making your code more efficient. So before we move to the solutions to the problems, I saw this okay this yeah, so this guy says he solved a number of a lead code user, he solved a number of problems on two pointer technique, and he was able to classify them into four categories. Oh, my network. So one of the categories was moving was yeah, what I mentioned earlier, when you have them at different ends and then you are moving both of them closer to the center. Another one was when they are starting together, but then they're moving at different paces. So it almost feels like a sliding window with that other solution. Okay, yeah. So he says number one, running from both ends of an array. So that was the one where I say this is the example I just showed now, running from both ends of an array. Then we have slow and fast pointers. So this one can look like a sliding window or feel like a sliding window when you are making use of it. Then we have this running from beginning of two arrays or merging two arrays. So here you're not dealing with only one array. You have two arrays and you're trying to maybe compare and do some comprising and merging of the two arrays that you have. And then for the fourth case, although he said there are no, it's not so common, splitting the array, divide and conquer. So it just shows that the two pointer technique does have applications in different areas. So now we move to the exam, the list code problems that we're going to solve. So this one is rather simple, flipping an image. Okay, so um, because it's simple, let me explain. Okay, um, while we wait for that. So in this flipping an image, we're given an array basically. I'll show the okay, what that loads. We're given an array and a matrix of arrays, not just an array, everyone or an array of I'm not sure how to put that. But you have arrays within arrays, so it forms a matrix. And what they want to do is flip the image. So how do you flip the image? You take you flip the image by first of all reversing every um you reverse every you reverse each of the sub arrays. You reverse this one, which this one becomes 0 1 1. This becomes still the same even after reversing 101. This becomes okay also the same. Then after you reverse each of the arrays within, you now you now should I say invert, in the sense that all the zeros become ones and all the ones become zeros. And how do you do this inversion? If you want one to become zero, you can simply subtract it from one, because one minus one is zero. And if you want zero to become one, you can subtract zero from one, which is going to be one minus zero, which is going to be one. So if you just do a let me just use a different color for this. If you just do a minus one, okay, so we do minus one for every element in the array. Minus one, minus one, minus one. We're going to have, okay, let me use a different color. We're going to have 110 at the top. So this is one, sorry, 100, 0, 1 0, and then 1 1 1. So how do you implement this? I'm going to use Python to implement it. So if I want to implement this using Python, what I want to do is that I want to swap this, I want to swap the ends. You know, this, I want to swap this, I want to swap this. I want to keep on doing that until the example here has just three, but you can have four, five, you can be more than three. So what works here is that if you just say as long as for a case where you have odd numbers, the value of as you are increasing this pointer from 0 to 1 and you are decreasing the pointer on the right, which is pointer 2, there will be a point where they will become equal. So for odd numbered arrays in terms of length, you can say as long as pointer 1, I mean, while pointer 1 is, should it be less than or equal to, essentially you're going to keep on doing it until the point where they are equal to each other, because at that when they are equal to each other, it means that that element in the center, it doesn't matter if you flip it or not, it's going to remain the same. But then when you have an even number of elements within the array, let's say you have 1 0 1, you're going to get to a point where you have the index here, the left index here is 0, you have 2, then as you increase it's going to be 1 1. Oh, I think I mixed it up. So it should be for the odd numbers. No, it's not. Sorry, this is supposed to be 3. Sorry. So you have 2 here. So for the even numbers, you are saying while j is less than, you are going to keep on flipping, because at some point, if you when j is 1, I mean sorry, when the left pointer is 1 and the right pointer is 2, yeah, and you flip this and inside that again, then the left point and you go and increment it again, and then this one becomes 2. Okay, this one becomes 2, and this one becomes 2, and then sorry, so this becomes 2, and then this becomes 1, and then you decide to increment it again. What eventually happens is that you are going to reverse what you have reversed already. So for odd numbers, you're looking at while j is, you're looking for the case, it, it stops when they become equal, and for this one is while j is still less than. So if you look at the code here, yeah, so I'm running one loop, if a general for loop outside. And what that for loop does is that it will make sure I go through every row, every array every sub array within the main array. And then I have a left pointer, which is left column pointer, and then I have a right column pointer which starts at the other side. So I'm saying as long as the left column pointer is less than or equal to cover for cases where we have whether even number arrays or odd number elements in the array. Make sure what you do is that you keep on swapping. So here, what I did here was that in my while loop, I as I am swapping, as I'm reversing, I'm also inverting, because I could have decided to come just change the values, maybe just do something like this. Uh, row, yeah, like this, then this, and then again I'll not gonna take time again to write another loop through the array again to now start changing all the zeros to ones and ones to zeros. But Python, you can just simply swap values like this with this kind of syntax using Python, and at the same time you can manipulate the swapped value. So what I'm doing, let's take an example for the first. Let's say I have a 0 at my left column pointer and a 1 at my right column pointer. So I'm saying let the new value in the left column pointer be 1 minus whatever is in the right. I've already reversed it and I've already inverted it. The same thing for the right. Let the new value of the right be whatever was of the left. But this time, before you just put it in, take subtract it from 1 to get the final value that we need. Then increase the left pointer, reduce the right pointer. Eventually when you run it, it's going to work. So yeah, when you run it's going to work. And I think as submit it, it also doesn't give any problems when you submit it. Okay, good. So now we move to the more difficult problem. It's also tagged easy on lead code, but if you've not seen certain problems before, you might have a little issue with understanding how it works. So, the what this problem wants us to do is to count the. I have to move quick. What is okay? Yeah, this is it here. So they want to count the number of binary substrings. What are the what is allowed here? Once you cannot have a case where in a substring all the zeros must follow themselves and all the ones must follow themselves, and they must have an equal number of zeros and ones. So if you had 0011, it is allowed. If you had 0011, zero is not allowed. Or if you had 001100 is not valid because there's a 1 1 in between the zero. So the zeros must be consecutive and the ones must be consecutive. So in this case, there are things we need to look out for. We want to keep track of three things basically. We want to we want to ask ourselves how many consecutive numbers are we currently looking at. So this is my pointer one and my pointer two. How many consecutive numbers are we currently looking at? Then, what's the total count so far for the ones that for the valid substrings we've seen? And then also, how many we're looking at the current number of consecutive numbers, but they has to be able to store the the number of consecutives that has not yet been added to the total as a way of just keeping like keeping track of what has happened, but we need to make some confirmation before we finally include it in our final in our total count. So that means that we're going to need three variables basically. This problem kind of felt like a sliding window problem because although the two pointers are going to be moving side by side throughout the entire thing. So essentially, you have one variable here. Let's say temp. Temp is always going to be one. Like it cannot be less than one because you you are assuming that right from the start that there there is a variable, and then you want to now know is the next so is the next binary digit, not variable, is the next binary digit equal the same thing as that current digit. So here temp is on one, and our pointer our pointer one here, this is our pointer one and this is our pointer two. We are going to compare them. um So when we compare, why you doing this? Okay, so when we compare and we see that they are the same thing, we are going to increase temp by one. So temp becomes one plus one. What does that mean? It means that we currently have two of the same digits that are following each other consecutively. Then we move to the next case. So at the end of this one, temp was two. So temp is the variable that is storing the number of current consecutives for a particular digit. So we've seen a zero and a zero and they are equal. So temporary means two. Now temp is still two, but then we now have a zero for pointer one and a one for pointer two. What's going to happen here is that you are going to compare here, obviously. And when you see that they're no longer the same, you still need to store the value of the value of the consecutives from the zero and zero, because there's a possibility that if a one if a one comes after this zero. I'm not using this particular case to explain how it works because it can scale it up or scale it down. So if a 1 comes after the current 1, then you have a valid substring. So you don't want to just throw away that value and then you just set them to whatever you like. So we can say, I'm not sure what kind of what I called it, but let's just say for this case, let me just check what I called it here. I think I said something like, okay, okay, not even temp, okay, consec. Okay, so let's just say last temp. So just see temp as a consecutive number thing. This is terrible. So the last temp is equal to, let me just text this out. So we have last temp will be equal to the current value of temp. Although before you do this, you now want to start making, you want to start accounting for the total count. Now, when we started the program, we're going to initialize this last temp to 0. So because so far at the start we've not seen, we are not measured, like we are not getting anyone that is confirmed yet. The purpose of last temp is you're going to use last temp to compare with temp to know if we're going to add to your final value, to where we're going to add to increment, because you're trying to take note of the previous and even the current. So your total will be whatever is smaller between last term, you add it, like you increase it by total plus whatever is smaller between your uh smaller between your last temporary and your current temporary. So your last set of consecutives and your current set of consecutives. In this case, the smaller one is, in this case, the smaller one is your last set of consecutive. So that means that total is still going to be 0 because you've not seen anyone that is valid and that you have confirmed that you can go ahead and add it, because you are still trying to check. You're still trying to check for what comes after. Is it going to be valid? Will it affect the current, set of substrings that you have? So you set your last temp equal to your temp because we've now seen two two binary digits that follow each other, but you still want to go ahead and confirm. So from there, you now move from last temp to temp, and then you set your temp back to 1, because before your temp was on 1 when you started with pointer 1 here at the beginning. Then it became 2 when you saw that pointer 1 and 2 were the same, so you had two zeros. Now you've come to this place where you have a 1. You have to set them back to 1 because you're no longer counting for 0, you're now counting for 1. And so temp has to go back to 1 so that I can properly account for the ones that are there. Alright. Um let's change this bit. Now we've come to this point here. So we've come to this point. What happens here? Temp is equal to 2. Why? Because 1, you know, 1 and 1 are equal. So that means that we have two binary digits that follow each other in the sub, two binary digits that are consecutive in a substring and are following each other like in the substring sha. Then um so your temp is going to be equal to 2. Then you run the same thing here. When you come to this point where 1, you have 1 here and you have 0 here, they are going to ask all this, they're going to do this exact thing again. So let me just get this. So here you're asking what is smaller between last temp and temp. Now last temp is equal to 2 and temp is also equal to 2. So none of them is really smaller. So you take any of the values. So that means that total is going to be now equal to 2. So total ends up being 2. Total is now 2 because, and how is it 2? In this, within this substring, again you set last temp equal to temp is 2 and then you set temp back equal to 1. But within this your substring here, we have 0 0 1 1, which is valid. And um, we also have 0 1, which is also valid. So using this technique, we're able to account for multiples and singles just by taking note of the current values, or the current value of the consecutives, and even the past ones that we've not yet kind of confirmed or accounted for entirely. So this is another method. This is another way you can apply the sliding. Sorry, apply the two pointer technique. So you keep on doing this until the end, and then you end up with the total number of substrings. In this case, it's going to be six. So let's just take a look at the code. So I had a number of comments here. Said consecutive keeps track of the current number of repeating ones or zeros. Last consecutive stores the last consecutive number before it resets, that's to one. Then the total stores the total number of consecutive substrings that can't be extended. Yeah. So basically, you had a zero, a one, then you had another zero. You cannot possibly have another substring coming from uh, that group. So you can just go ahead and add it. So you initiate your consecutive num to one. Your last consecutive num is zero. The total is initiated to zero. You have your pointer one starting from index zero. You have your pointer two starting right beside it. And then you begin to loop through the using this code, you begin to loop through array, the array now. Yeah, you begin to loop through the string basically, and you check all those things. If the two values are equal, then increase the number of consecutives. Sometimes you can have 0 0 0. This consecutive number will get to three. It's not only two. Let's stop at two. So if they're not equal, then if okay, so I just this is there's a function that does this in Python, but I just did this just to make it clearer. That what I'm saying is that if they are not equal, yeah, you increase the total count by whichever one is smaller amongst them. Because that doing whichever one is smaller is like a, let's say, safety net. You are looking at what is already valid, what can we go ahead and add, what won't be adjusted eventually. So you can also just implement it like, let me just remove this. Just implement it like this in Python. Yeah, and it will give you what you need. Then after you increase total count or add total count, okay, let me remove this. You now um you set the last consecutive set of numbers to the current one, because the temp you have to do that because you are going back to one, you are resetting it. So you have to now keep track of the current one before you reset, so that you don't lose it. And then you reset your consecutive number back to one. Then you have your, okay, I just use this print statements to is solving my problem. You don't need them here. um yeah, then you move your pointers each to the right. Then okay, so this total outside here is for a case where, let's say, you have the last one, it doesn't, is not a, maybe you have a 0001. In that kind of case, because the last two numbers are not equal, this total mean here inside is going to add the one before it goes to that point. It's not yet have accounted for it. So the total mean, okay, let me just sketch that out a bit. So you have a zero, 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 and the one. Then you have some other set of strings here. So the first total the first incrementation for the total, which is this highlighted portion here, is going to account for um where's this? Let me change the color. It's going to account for whatever value you had before you got here. Maybe something, let me make this neat. Maybe there was something here before you got to this point where you had 0 0 1. But this total plus outside here, this one, is going to account for the final set here, because the last consecutive is definitely going to be uh, in this case your consecutive norm is probably it's going to be one. Even if your last consecutive norm might be greater, your consecutive norm here is going to be one. And so when you come out of the entire uh, while loop, When you come out of the entire while loop, this case here, where is it? Yeah, it will take care of this for you, adding one more to it. So that is how you can use the two pointer technique to uh, solve problems. So the time complexity of this is O of n, because you're only running one while loop. So and you have to go through the entire string. So it's O of n here. And the space complexity is also is O of 1, because you're not using any extra space to do anything. The same thing for the flipping image question. The space complexity is O of 1, and the time complexity here is um the time complexity here is going to be probably you have an outer loop which is O of n, then you also have an inner loop. Okay, so in this case, let's say maybe I think O of n log n. Yeah. So we can see that both cases, the two pointer helps to reduce the uh, time complexity, and it just makes the code more efficient. So thank you for listening. That would be all uh, for my capstone project. Thank you very much.